Um, so you've had 3 days of fairly deep, exotic tours through the bowels of the JVM, and I'm mostly not going to talk about any of that stuff. This talk, I started thinking about things that bugged me over the years, and didn't come up with any like consistent themes. So I ended up with like a bag of torn, dusty sandpaper, which is kind of what this talk is. And one of the things that has really impressed me for my whole life is this idea that knowledge has kind of a fractal nature, right? That the deeper into it you look, the more complicated it gets, right? So by my clock, Java is 33, 34 years old. And there's always new depth that people find. I mean, there was that one talk on Monday about string concatenation, and how you can do an actually quite interesting, deep, nerdy talk that is nothing but string concatenation. And then you get into the head exploding stuff like Valhalla, and just about every other topic at this conference. The closer you get, it's always more complicated, and there are dragons everywhere. It's really, really kind of queer. So a little bit about me. I have more gray hair than most of you. I've never been a follower of best practice style guides. In the Java world, I come by it naturally because I just did whatever felt right. And I tend to skew towards like functional programming, but I've always viewed functional programming as kind of a more a style than something that one would freeze into a programming language. Because every time that I've seen people try to do functional programming languages, there's always something that kind of leaks out and they become kind of non-functional. But I've always written in a fairly functional style. And probably the one thing that causes coworkers of mine the most heartache is that I really, 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 really like density. I like to get as much code in front of my eyeballs as possible. And that tends to drive a bunch of things. And some of it turns into me using some Java features oddly. I don't know if any of you, or how many of you remember Mike Doiju? He worked on Java for years and years. And we worked together in other places in multiple times. And he currently works for AWS. But he once did a talk that was essentially, what I've learned from following James Gosling around and cleaning up his code and coping with his weird idiosyncrasies. I think it was actually a Java 1 paper of like 10 or 15 years ago. And he actually asked me if it was okay for him to give the talk, and I was like, yeah, sure. And another sort of weird thing about me is my first programming language was assembly code. You know, I started out in PDP at assembly code, graduated to CDC 6400 code. Did assembly programming for a large series of machines that haven't existed for decades. And somehow I find that even now, I am still detoxing from that. So some of my programming weirdness comes from me trying to write code to help it just be fast. And that is one of the most ludicrously stupid things to do these days, because the compiler tools have become so freakishly awesome. I mean, it's now essentially impossible to write assembly code that can compete with even a half-decent compiler. And, you know, in my immediately previous life, you know, we did all kinds of benchmarking between different code generators and, you know, using, you know, LLVM underneath Hotspot and Hotspot by itself and Hotspot is fucking amazing. It is fucking amazing. You know, just garbage collection, right? I mean, by a fairly wide margin, the best garbage collectors on the planet are all in the Hotspot JVM. And, you know, they pretty much all have their sweet spot. And, you know, depending on what you need, you can go back and forth. But, you know, at my previous employer, Amazon, you know, Amazon has a fairly large engineering group supported to nothing but the Java VM. And, you know, that group has no trouble qualifying for its budget because it saves so freaking much money in hardware. Just traceable, you know, if they ignored everything except the garbage collector. I mean, the garbage collector cut hardware usage by a crazy amount of money. I don't know. I don't actually know the numbers, but they're insane. So thank you. Thank you to the Red Hat folks. Thank you to the Oracle folks. Thank you to everybody who's committed to all of the JVM work, but in particular, the garbage collector. And in the sort of stuff that I've done over the last 15 years, the fact that the latency has come down so much, and I've mostly lived in worlds where scale in terms of like millions of threads has not been an issue, but trying to get sort of guaranteed jitter to be measured in small number of milliseconds and sometimes even sub-millisecond ranges has been beautiful. So thank you again. So functional is the style. And so this is the same function written in two styles. The top one is the one that I like. And the bottom one is the one that conforms closer to, you know, many style guides. And I find that the bottom one with all the braces and the indents and, using like 3 return statements and spreading it out. I mean, lots of people seem to feel like spreading it out makes it better. And whereas I like to see it more compressed. And if I was doing a programming language just for me, the if statement would cease to exist. And I would do everything with question mark. But I might then be like the lone user of that language, which wouldn't bug me much. And some things like the use of pattern statements of pattern matching. Thank God for that. It's like the last Simula feature that I miss. And I know half of you are going, Simula? What's Simula? It's, this simulation language, the official spec dates to 1967. It was a real groundbreaking language. It was the first programming language that had object-oriented programming in it. And I fell in love with it and fortunately had access to the source code. And oh man, that was so much fun. And they had something that was very much akin to pattern matching. And I, for years and years, every time I had to do like contortions with Instanceof and that, I always like, damn, I want Simula back. But that's all gone. I'm so happy. But a lot of people find this sort of winding of multiple statements into one statement. And some of the code that I write is much worse than this. It gets really contorted, but I find it really readable. Another weird thing about me is if I can avoid allocation, I do it, which more often than not turns into recursion. And so this is a simple routine that converts an integer into a string of characters. And you look at most code that does that, and it allocates an array and fills in the array of characters and goes boom. But I like the recursion one, even though, once upon a time, it was faster to do recursion than it was to allocate an array. These days, it's faster to allocate an array because almost always the array ends up being inlined. The performance of new has gotten like so amazingly good, and has been for a bunch of years. But it's a reflex I can't escape. And I tend to love hideous hacks. So, like I really like the string template feature that came out a couple of versions ago, but I mostly like it not because I use it the way anybody else does it. In all the documentation, they talk about a string template as something that is used to generate something else that you then shuffle onto somewhere else. And most often, the output of a process method is a string, right? And it ends up doing a giant string concatenation. But then I sort of looked at it and went, oh, I can put state in there. And so I've got that, private writer out, and I just put that in the constructor, And then the average use of it is something like you say you've got a static variable, like in all the documentation you see people go, stir dot quote, and then they append that to some, send that, they'll do a println of stir dot quote. And there's no println here because I put the writer into the string template processor, and the string template processor doesn't concatenate all the pieces together. It just says out.append. And so what is normally like a whole pile of string concatenations or string builder.appends is appends to the final output. So I get to eliminate one whole level of copy on things like log statements and debug statements and stuff like that. And it's grotesque. Most people who have seen this, their stomach churns, but it makes my heart sing. So I keep doing it. It could be worse. With default methods and the way you can extend interfaces, making appendable be a string template processor. So you could say something like appendable dot quote hello world, and then all of a sudden it just works, and one whole level of copy goes away. And when they're really large, the string concat completely disappears. And if you do it on appendable, then saying writer dot something or other works, and it's this like toxic waste that goes everywhere. And I'm sure wherever Brian is, his skull is vibrating. So I wanted to make a sort of a historic comment that many of you probably don't know, is that so annotations, which I know people who think of annotations as the #1 feature of Java, just because the kind of things you can do with it are just so freaking awesome. But long before Java came out, or literally in 1991, Java had annotations. But the way that they were done in that early version of Java was that keywords, class names, and declaration modifiers had distinct namespaces. The way that this worked in the parser was if there were 2 or more names in a row, then that was a declaration. And you've got this group of words. The last word is the variable being declared. The second to last is the type, and all the ones before that are all modifiers. So you end up with them in different namespaces. And keywords, strangely enough, were not in the lexer. And that was kind of cute. It was kind of useful. And I really like the ability to be able to add annotations to declarations and that kind of stuff without perturbing the language by having to add keywords. So the things that are keywords now were not keywords then. But at some point, some of the users of Java discovered that public equals 5 was a valid statement. because, so that's a public declaration of an instance of the public class whose name is public. And somewhere before that, there was probably a line that said public class public to define the class named public, which was itself public. And I thought that was cute. When people figured this out, I basically had an army of people with baseball bats. And there were a number of annotations that were in use at the time. So I sort of gave in, and then keywords happened. And that was in really early '92. And the most used annotation was transient, which was just a feature of a serialization technique that preceded RMI, which died long ago. But that annotation, the only way that could survive is if transient became a keyword, and a modifier bit. So people have always been kind of weirded out about like, why is transient a keyword? And it's like, oh well. And in retrospect, it's clear that they were right and I was wrong, because public equals 5 is clearly toxic waste. The C heritage has often felt a little uncomfortable. Got into that, because we were trying to get people. It was kind of a scam to get people to be comfortable with this. It was kind of like dressing rocket science up so that regular software engineers would be comfortable with it, and that worked really, really well. I mean, I don't regret the C heritage at all. Some things have not aged too well. The one that's probably the most painful for me is braces, for kind of odd reasons, but I'll talk about that later. Sometimes it gets kind of wordy, even though I am the guilty party for Instanceof. I regret it being spelled out like that, because I use Instanceof a lot. Unsigned is probably the thing that I get the most email about in terms of, why did you do that? And that was another one of these ones where I love to do sort of science experiments around programming language design, and I went up and down the halls and asked people puzzle questions about how unsigned worked in C, and basically beyond the really simple stuff, everybody flailed. And the other piece of the C heritage, and probably the thing that bugs me the most in my day-to-day life, is that the syntax of cast is a complete atrocity. I'm not sure how that came to be, but that was one of those ones that's like, if you do it any other way than the way C did it, then people just won't, so. And I think back then I was like, oh, this is fine, this is okay, I don't care. This is what I've been doing for the last 20 years. But now I look at it and it's just weird. because it's kind of like there's an implicit operator in between the type and the thing, and the fact that there's a mandatory set of parentheses around the type, which is kind of what you have to have in order to make the thing parsable. It's just, braces. Why do braces aggravate me? I mean, I mostly love braces. I mean, when C first came out and I started using braces in 79 ish. I was kind of a latecomer to the Unix party. You know, it was a real breath of fresh air, because most other languages you had to spell it BEGIN or END, or you were spelling like FOR and then ROF, or do and then odd. You know, as conventions go, most of them I had a hard time with, and braces were a breath of fresh air. But sort of as time progressed, you know, their usage became kind of inconsistent. And probably the number one things that bugs me about braces is that it starts arguments. You know, the number of hallway arguments over brace style, you know, should begin braces be at the beginning of the line or the end of the previous line? Should you put an else after a closed brace? And every time I see one, I start hearing one of those arguments in the distance down the hallway, I just run away. I just don't want to be there. And these days, you know, if I was doing it over again, I would probably mimic Python, because Python doesn't have braces. It just uses indentations, and there is no argument over how you do indenting, because there's just a law, and the argument disappears. Of course, I kind of hate Python indentation because it reminds me of parts of the COBOL spec. And probably doesn't bug any of you, but as somebody who has, you know, had to admit to accepting money to write a COBOL compiler, you know, that sort of felt unclean once I got to the end of that job. But you know, there are some language choices that just are invitations to argument, and actually most of them are. Declarations, oh man, I loved C's declarations. I kind of didn't like the way that like square brackets were done, so I supported both the C style and the style that felt sane to me. Around 2002, I wrote up a proposal paper for a list of language changes, and one of them on it that I liked quite a lot was because type inferencing was starting to get better and better in Java C, to just do declarations using type inferencing. And the syntax I was using in that proposal was v : equals 24 or whatever. And of course, that went nowhere. And I still like it, if only because it's briefer than var, and it's usable in an expression. And being usable in an expression, that sort of that excites the functional programming side of my brain. And you know, at the time, lots of people were appalled by the notion of declarations and expressions. And yeah, I get that. But the thing that today I find weird is the patterns in instance of, because a pattern in instance of is essentially an assignment and a declaration in an expression. And I commit so many abuses of instance of these days that it's really kind of appalling. I often use instance of as a synonym for not equal to null, because I don't actually care about, I mean, because, you know, I'll say instance of, you know, the type that it's actually declared to be. So I can then use that in an expression where it's like that question mark, the variable, colon, you know. And, you know, there are a lot of languages that have funny little notations for, you know, things like dot question mark, that it's like, or question mark dot, right, where it does a test for nullness and then you get this or that. And Java has that, right? It's just spelled instance of. And it's a little clunky, but it works. And I love it. Another thing that sort of, you know, back in the dawn of Java, one of the things that I spent a bunch of time thinking about was the symmetries between cast and instance of. Because cast is this weird thing with this sort of prefix syntax. And the prefix form of it just felt annoying. And so instance of was done more as an operator. And I was often really wanting to do instance of more in the syntax of an operator. You know, so, you know, when I had written thoughts about this in the past, it was always some sequence of magic characters like colon, colon, and, you know, doing instance of as colon, question mark, colon, and that just gives you the symmetry, you know, most people don't think of cast and instance of as being symmetric, but there is a really strong symmetry between them, especially once there's pattern matching added to instance of. And something that captures that symmetry would be pretty damn cool. And this isn't really a language thing. This is very much a style thing. You know, if you read a lot of style guides where people talk about the use of exceptions, people generally think that the only appropriate things to ever catch are sort of runtime exceptions, the things that people throw. But I kind of have this belief that all code is buggy, and you do as much testing as you can, but there will always be bugs. And there are situations where if there are undiscovered latent bugs, you want to still soldier on. And lots of times in the cloud world, that really isn't an issue. But you know, if your Java program is in a box that's nailed to the side of a post somewhere in rural who knows where, soldiering on is a big deal. And in the cloud world, just soldiering on is often a really bad idea because you can have corrupt, but then that turns into blast radius expansion, right? And so the atomic unit of blast radius is then the JVM process. And when you're living outside of the cloud, the kind of blast radius you'd like to have is actually smaller than a process. So I tend to use try, catch, throwable a lot. And I know people who come to my code, they find that hard to believe. But then, you discover that, that gas meter nailed to the side of a building, if it gets an exception while it's posting a log entry, it doesn't crash. It doesn't go sidewise. It probably retries things, whatever. There are literally satellites in the sky that don't go sideways just because I do that. So I was editing these slides on Monday, and somebody sitting next to me at the table said, "Oh God, if Brian sees that slide, he'll explode." And so I decided the right thing was a trigger warning. So operator overloading, yay. And in general, all of the experiences that people have had with operator overloading in like the C++ world are that it's very cool when used appropriately, but hideously easy to abuse. And most of those abuses, it's like one of the few engineering activities that I consider worthy of capital punishment. It can be really, really bad. But nonetheless, back in the early 2000s, one of the things I was working on was the early version of the NetBeans refactoring engine. NetBeans has this refactoring engine called Jackpot. And strangely, its descendant is still in NetBeans. But I did this experiment where I'd have these big lists of refactoring rules. And one of the things that's weird about the Jackpot engine is that the performance of a refactoring operation is almost entirely independent of the number of rules. So you can have hundreds, if not thousands of rules, and it's still fast. And so I was doing these experiments where I would parse bags of code, pretty print it, run a refactoring, pretty print that, and then either diff it and eyeball it or just count the characters to see, because I was trying to find, what language things would actually make a difference in compressing. And I tried lots of different things. And one of the experiments I did was about operator overloading. And operator overloading had almost zero effect. And certainly all the ones that people think about, like, plus, minus, whatever, even though when you look at some of the math code, like what people do with big decimal and that, can be kind of clumsy, and operator overloading makes that cleaner. There's so little code like that it gets difficult to see any value in it. But a lot of that is because, for a variety of reasons, people don't do a lot of math in Java. And, with some of in my sort of 2 lives ago for me, I ended up doing a lot of math, which was a lot of fun, and I would have dearly loved operator overloading. And if Valhalla finally solves its last PhD thesis, then a bunch of things can explode, and a bunch of those would be happier with operator overloading. And I certainly like the notion that operator overloading is kind of like an all or nothing thing, right? It's really about math. But I tried a lot of different forms of operator overloading, and there was one that actually made a huge difference, and that was operator overloading of accessor methods, right? So turning a.get of k into a sub k, just using subscript and then subscript assign. That one did a lot, and turning setters and getters into what looked like field references. That one makes me kind of queasy, but it certainly made code look a lot cleaner. I do love Unicode. So there was a library that I wrote a dozen years ago, and this is actually functioning Java code. When you're writing stuff that's math, and if you're as math challenged as I am, right, you're always like looking at all kinds of weird books, and they all are using like Greek letters and all of that, and it makes things a lot more comprehensible if you just use Greek letters. So that file is 100 methods that all look like that. And yeah, it makes my heart sing. The fact that delta lambda, for instance, is actually a valid Java identifier is like, yes, thank you. There are a few things that kind of might like the first 2 lines here, static final double pi equals math.pi. I just put that in a lot of files just because. E, I don't use E very much. I've actually done there is a Unicode character for the empty set, and static final object phi equals null is strangely cosmetically positive, even though I can see Brian clinching. In my last project at Amazon, which was like my last 3 years at Amazon, which died in the AI apocalypse because it wasn't AI. So one of the pieces of it was a small scripting language. And I kind of went full Unicode. I didn't go as bad as Guy Steele did, but things like greater than and less than or equal to and greater than or equal to worked really well. There are superscript digits in Unicode, and I use them as functions. So x squared, that's a function call? Works for me. But I fully acknowledge that way lies madness. I mean, the first one, maybe the second one, are moderately sane. I would almost suggest putting that into, Java lang math. But after that, it's like, yeah, no. Miscellaneous stuff I didn't know. So record. I did a little survey a while ago of usages of record that I could find. And people talk about like the semantic differences and how this is, and then, oh, by the way, it has this syntax sugar on it. I couldn't find any usages where the semantic niceties actually made a difference. It was all about, that's how I can get the syntax sugar. And it's like, why isn't that in class? And like, I think I basically said this next one, is it evil to use Instanceof as null check and assign? I don't think it's evil. Several people have, I have debris from exploded heads that I still need to clean up because it is null check and assign. It's great. Even though I know why var can't be used for class fields, for fields in classes, this is not always the case that it doesn't work. And that would make life lovely. Valhalla. So strangely enough, I've been banging my forehead on this since 1981. And where the head banging started was, for any of you, any Lisp programmers here? Yeah, so particularly in earlier versions of Lisp, there was a way to do declarations, right? So normally you would just write your Lisp code, and then to make it faster, you would decorate it with type annotations. And you'd say fix num this or flow num that, and usually a few other things, but fix num and flow num were the ones that really made a difference. And that sort of worked. The problem was that it blew their object model, and the semantic differences between a regular number and a fixed num, the fact that a fixed num was bounded usually to like 2 to the 30th bits, because they would use the bottom bits for flags and other grossness. And also, since they would do automatic promotion, so if you said a equals a plus 1, it would graduate from being a fixed num to being a regular number, and maybe even graduate eventually to being a big num. And that caused equality to go sideways. And all of that tearing was a major pain in the ass in my PhD thesis. I burned many hours on that. And then when it came time for Java, I really didn't want to do primitive types. and I did a lot of headbanging and eventually just gave up because there was just no way I could see. And, you know, it felt like everywhere I looked, there was another PhD thesis topic. And I am so awe-inspired by the fact that the group here has put so much effort into Valhalla, and you know, found so many PhD thesis topics that I didn't know were there. You know, it's often felt to me like the Java engineering community should be a degree-granting organization, because some of them are really hard. And some of the ones that you guys are probably not even aware of, like in Swing, there are paths. And you can do geometric intersections and unions of paths when you do clipping and that kind of stuff. But you know, if you imagine you've got two shapes and you've got A and B, and you compute A minus B, and they say like, and you compute A minus B, so you take a notch out of it, and then you compute A minus B plus B, you end up with a region here that is perfectly smooth. But in fact, since all of these coordinates are floating point, they're slightly perturbed. And so what you end up actually is, if you follow along that curve, you'll find that instead of, you know, one tightly meshing curve, what you find is these sort of sinusoidal bumpy things that intersect and create billions of holes that are all subpixel sized. That should have been a PhD thesis. And so one of the things that I have wanted for a long time, changing subject completely, is some way to do sort of link loading or sort of load time remapping of APIs. And you used to kind of be able to do it sort of pre-JDK9, because in your file you could re-implement JavaNet HTTP and have your own private implementation, and everything would get it. And for many reasons, that's just a really stupid idea. But so like in my project of like 5-6 years ago, we had a serious space problem, and everybody was saying, "Oh, the JVM is huge." And you know, you do the accounting on the JVM, and it's actually not terribly huge. But then you start looking at the libraries that are used, and there are two kinds of hugeness. One is, you know, you use a routine in Apache Commons, and you know, then you've got this like giant jar file, but mostly that doesn't actually get paged in, doesn't actually get linked in. The biggest killer in that particular examination was HTTP. Right? So like if you touch anything in Apache Commons, you get Apache Commons HTTP implementation. And an HTTP implementation is not small, because HTTP is ferociously complicated for no good reason. But if you use any of the Google libraries, they have their own HTTP implementation, which is also ferociously complicated. If you use any of the AWS APIs, AWS has its own HTTP implementation. And we ended up finding that we had 5 HTTP stacks loaded, all of which were being actually used. And their APIs were just like pretty damn close. And man, did I wish for some way to be able to map them to one thing. And I have no clue how to do that. Because it's never like the big ticket items like doing HTTP GET. It's all the small nits in the APIs. So I'm resigned. So thank you. That was a low-tech rant. Questions?
Any thoughts about finalization?
Oh man. Yeah. Well, I mean, that's kind of in the same bucket as thread.stop. You know, the thing you never want to build and yet can't avoid. You know, the things that are just too easy to abuse. You know, the number of people who put, you know, all of their flush the data code into finalizers. It's like, no, you don't know whether that finalizer is going to get called. You jackass. I don't think we'd survive without finalizers. And yet, you know, we've had near-death experiences because of finalizers. Same thing with stop. I've seen a very small number of valid uses of stop, but not zero. So nothing profound. Anything else?
I wasn't going to find it by the time he brought over the mic, but I got a very early Java book at a Savers, and in it there was this block which is like all the access modifiers, public, protected, and then it was like private protected or something. I was like, what the hell is that? Let me find it. Maybe I'm hallucinating.
Oh, it was. Well, there was the unstated modifier of friendly. You know, it's the modifier you get if you don't put a modifier on there. And there was a I forget what it was. It was a public protected or whatever that eventually disappeared. But that one was fundamentally a Bill Joy brain fart. But yeah, that one never went anywhere, and was never going to go anywhere. Other questions? All right, I guess. Oh. I think there was actually one more hand came up.
You don't get off that easily. When can we confirm you for next year's Java 1?
I don't actually have much influence over the answer to that question, because my wife controls the social schedule.
So when can I ask her?
Yeah, I don't know. Depends on how. let's talk a little closer. Yeah. Anyway, thank you.